In this lecture, we will be taking a closer look at the Köppen climate classification system and a handful of the climate regions that are important to this course. The Köppen climate classification system is very much the most widely agreed upon system of organizing climates and climate types. It is named after the German climatologist Vladimir Köppen, born in 1846, who ultimately organized the many climatic regions of the planet according to long-term patterns of temperature and precipitation. Initially, Köppen identified 5 major climatic groups. 4 of these groups he defined as heat zones. He specifically looked at long-term patterns or annual patterns of temperature and temperature fluctuation. Today we use a much more comprehensive system, but we have kept Köppen's classification scheme. We identify 5 major climate groups, groups type A, B, C, D, and E. These groups are then subdivided into a total of 14 individual climate types, what I will be calling subclimates. So we recognize a tropical group, a tropical humid group, labeled with generally A. We recognize a B group, a dry or arid group. We recognize a mild mid-latitude group, which would be identified with C. We recognized a severe mid-latitude group, D, a polar group, E, and then we have a specialized highland group that we recognize as H. So this has been an additional group that has been added over time. Now within this, then we break things up according to smaller subregions. So within our tropical group, we have a tropical wet, tropical monsoon, and tropical savanna. Within the dry group, we recognize a subtropical and a mid-latitude, and we break those down a little bit further. Within the mild mid-latitude, we recognize a Mediterranean, a humid subtropical, and a marine western coastal climate. Within the severe mid-latitude, this would be again represented by the letter D, we recognize a humid continental and a subarctic group. Within the polar group, we recognize a tundra and an ice cap. And then the highland group, as I mentioned before, which has been added over the years as a kind of a specialized group, we only recognize the highland type. The reason why we have all of this diversity and how we're taxonomically organizing our global climates is because when you look at the map of climates and climate types, it's very pocketed in nature. For example, if we take a look at tropical wet subclimate types, or it's a kind of tropical humid climate, which we label as tropical wet or capital A small f, you'll find that there are portions of southern Venezuela and northwestern Brazil that can be classified this way. But then we also have the kind of northwestern and northern portion of the Democratic Republic of the Congo that can also be identified as such. The plants, the animals, even the expressions of human culture that have developed in these areas that, though they may not be connected, have nearly an identical climate type, they will also align themselves. So it is a system that on the surface is very, very confusing, but as you begin to study this a little more closely, and as some of your course exercises will ask you to look deeper into this geographically, you'll find that it really brings a lot of order to a very pocketed kind of map system. The mesothermal or mid-latitude climate group, or group C, generally occupies an equatorward kind of margin of the mid-latitude regions. It extends farther poleward along the western coasts of continental bodies than along the eastern coasts. It constitutes a kind of a transition between warmer climates or warmer tropical climates and colder, severe mid-latitude climates. In the regions that are classified as type C, we find that the warm months generally will have average temperatures that are above 50 degrees Fahrenheit, whereas the cooler months average temperatures at or just below rather just above freezing, so at or just above freezing. Within this group C, this mesothermal or mid-latitude group, we recognize abbreviations such as capital C, small f, small a, humid subtropical subregion. We recognize a marine western coastal subregion, CFC, and a Mediterranean dry subregion as well. The Mediterranean climate type, for example, generally encapsulates or classifies climates that are found on the western side of continents, centered on latitudes at or around 35 degrees north or 35 degrees south, depending on the hemisphere that you're in. Generally, annual precipitation for this subregion will be limited. In the winter, you will see precipitation being, accruing in this case. In the summertime, you will see it virtually without any sort of precipitation, so it'll be very dry in the summer months. Winter temperatures are generally mild. They're unusually mild for the mid-latitudes, and summers vary from warm to very intense, very hot. Skies will generally remain clear year-round with abundant sunshine, and this is especially the case in the summer months, and hence the reason why it's kind of labeled as a Mediterranean climate. The Mediterranean Sea and the coastal regions around it very much are, they typify this subclimate type, but also they express winters and summer months very much in this manner. Let's take a look at another subregion within Group C. This would be the humid subtropical climate type. Generally, again, the Mediterranean climates are found on the western side of continents. These humid subtropical climates are generally found on the eastern side of continental bodies, centered usually around the same latitude as our Mediterranean subtype. Other geographic regions include the American Central Plains, the lower eastern coastline of what is today Italy, at least northern portions of Italy, the coastal regions there, southern China and their highlands, southern Japan, and then Argentina. So what is life like in a humid subtropical subregion? First and foremost, summer temperatures in these humid regions are generally warm to hot. They have very high monthly averages, in this case somewhere between 75 and 80 degrees Fahrenheit. In terms of precipitation for this humid subregion, generally we will see summers as having the highest amount of average precipitation, again usually associated with onshore flows of convection air currents. And in terms rather of winter temperatures for the humid subregion, generally we would consider them to be mild. We see very low average expressions of both temperature and precipitation. However, with this humid group, you will have some extremes, but they will be very pocketed in terms of winter weather. Plants in this humid subtropical region have adapted to winters that have pretty severe weather, again in pocketed formats, with extreme, almost killing expressions of frost that extend for a few days at a time. However, the winter periods here are considered comparatively to be generally dry. So hot, moist summers influenced by moist tropical air masses and air flows that are moving along shorelines or moving shoreward. The summers and most of the year, with the exception of the winter months, would be again warm, moist. They would have a lot of storm activities due to unstable air masses, at least in the eastern and southern coastline environments. Of course, leading to pretty heavy, yet again pocketed convection showers or periods of rain that are driven by these convection currents of both air and then ultimately the temperature and some of the current activity of water. Again, looking at this particular map and kind of superimposing some of the regions that are typically humid and subtropical in nature, we would turn our attention to, in terms of the North American continental body to the kind of southeastern portion of the continental United States, we would find a similar but more extreme expression of this kind of weather and climate type in the kind of northern portion, coastal of California, and of course extending even into coastal portions of the western coastline of Canada, and then the southeastern coastline of what is today Alaska. In Europe, we would find again this humid subtropical climate type in its more extreme forms on the western side of the Mediterranean, extending across toward Spain, and then, of course, including things like North Africa. And then we would also kind of identify some more milder expressions of this in places like Western China or the north western coastline of what is today Australia. All right, so we'll turn our attention away from Group C and some of these subgroups that, at least two of which that I described to you, and we'll focus on the severe mid-latitude climate group, or what I call here the microthermal climate type. As we take a look at the microthermal climate groups, we will kind of focus our attention on upper latitudes and regions that are generally cold rather. The seasonal patterns for Group D are going to be long-term, but they will be extreme in nature. When you think about the land masses that surround the American Great Lakes, all of these in some form or another will conform in terms of their climate to this microthermal or severe mid-latitude climate type. So this severe group occurs only really in the northern hemisphere, because in the southern hemisphere we have very limited land masses. But if we had a greater degree of continental landmass in the southern hemisphere, you would see the same kind of reflection and at the same kind of higher latitudes. In this case, in the north, we find this severe mid-latitude group expressed between 40 and 70 degrees north. There are two subtypes that are recognized for the severe mid-latitude or microthermal climate group. We have a humid continental expression, and then we have a subarctic expression. So when you look at, again, the Great Lakes, for example, in North America, the northern border of the Great Lakes region, that portion that is well into Canada, would fit into the subarctic, whereas the southern border, which would include the Lake Michigan lobe, that would be associated with more of a humid continental expression of this climate group. Now, in terms of Northern Europe and Eurasia, we would see this particular climate group or this climate region incorporating and subdividing really places like Norway and Sweden. The northern portions of Norway and Sweden would fall into the cooler subarctic expression of it, whereas the southern border that would be pushing more toward maybe the North Sea, the coastal region associated with the North Sea, that would be associated more with a humid continental. If we look at Eurasia, we see that generally most of Russia is part of this group D. We see portions, actually, if you look at Kazakhstan, basically you can slice it into a northern and southern section. The northern section would be part of the subarctic. The southern section would be very similar to this humid continental expression. And again, it is very much of an expression that is common to the seasonal weather patterns of Wisconsin. So there are similarities there. Portions of northwestern China, and then like Kazakhstan, Mongolia itself can be sliced into a northern and southern section. And so that's kind of how this D group, this regional group, is expressed in that northern hemisphere in terms of its geography. Within the microthermal climatic region, then we recognize a variety of subregions, and generally these will be broken down again into a kind of two major groups according to seasonal patterns of weather, again, temperature and precipitation. Now, as I said before, the majority of readings, including the readings for this course, will divide the severe mid-latitudes, or this microthermal climate type, into two major distinctions. I'm recognizing that the humid continental subregion can be further divided down into a warm and a cool. But then there's the Arctic, the subarctic subregion, and that kind of is localized to itself. This may help in understanding how the classification scheme deals with some of the pocketing that occurs in the chiefly, again, northern hemisphere. So there's a warm, humid subcontinental type that would incorporate a lot of the experiences that people have in places like the Midwest. Then you have the cool, humid continental subregion. That would just be to the north of that in places like Canada, and then of course Alaska, if we're kind of staying to the kind of northern or the North American experience there. And then of course the subarctic region, this would include, if we stick with our North American examples, the Bering Sea, things like that. So again, each of these areas is experienced a little differently. If we take a look rather at this next graph, you can see how summers and average temperatures, including year-round precipitation, is experienced in both. Really, when you move from a warm, humid expression to a subarctic expression, you're moving toward things like a winter drought as being more common. Year-round precipitation is present in all of it, but you will see a greater distinction between summer and winter in a subarctic subregion. So that's kind of the trend there. In terms of course temperature, well, as you're moving toward those polar regions, you are getting longer and longer or more sustained periods of cooler temperatures and more extremes. Take a moment and look at the Arctic and subarctic and northern portions of the mid-latitude expressions of this map, and get a sense of the land masses and some of the nation states' continental landforms, and in this case marine and freshwater phenomena that are localized to these regions, and you'll start to see a pattern there. Next we have regional climate group B. This would be the dry climates, covering approximately 30 to 35% of the landmass of the planet. Here we have more of a climate zone in terms of how it's experienced, and it becomes pretty predictable in terms of the weather patterns and patterns of both temperature and precipitation that we associate with it. When you look at some of the map resources that you have for the course, you'll see that really the largest sections of the globe that are categorized as type B really fall into more of the kind of subtropical latitude environments. This is especially the case in western and central portions of some of our continental bodies. Now within this, we recognize two major subregions, desert and steppe. And what we find in these particular regions is that they're generally categorized, or they're characterized in a sense, by a climate system where the moisture demand exceeds what the region or the landscapes within the region receive on an annual basis. And as is the case with all of our subregions, generally they are going to be recognized and created or separated out as subregions because of their unique expressions of precipitation and mean annual temperature. The two that I will focus on in terms of our lecture series relate to the hot, low latitude desert environments. This would include tropical and subtropical deserts, such as what we find in places like Egypt and Saudi Arabia, and then also the cold mid-latitude deserts that we associate with in this case, southern portions of what is today Russia, and of course, some of the more arid regions in states like Nevada and New Mexico. And again, what you'll see as you're kind of reviewing this material is that we're dealing either hot to warm kinds of annual temperature expressions, or rather cool or cold temperature expressions year round. Rainfall, again, if any, in either of these subregions is recognized as deficient. Additionally, both of these subregions that I am discussing here in lecture really fit more within the desert expression as opposed to the steppe. A lot of the steppe environments actually represent buffer zones between the desert regions and, for example, tropical or subtropical environments. So a subtropical steppe climate, for example, abbreviated as capital B, capital S, small h, it is a steppe climate that generally will surround in this case, climates listed as capital B, capital W, small h. Except on the western side of some of these regions. It'll separate out the deserts from more humid climates. For this steppe environment, we also divide it into a hot and a cold expression. So we have the hot, low latitude steppe subregions. And again, we find these in places like central Russia. Iran is a very good example of this, also throughout Turkey. And then we have the cold mid-latitude steppe environments, which would again be very common to what we have in the United States and South America. We have, in this case, Utah, Wyoming, Montana, expressing a lot of that year-round mid-latitude steppe expression, and then also places like Argentina. Finally, for our purposes here, we'll take a look at another extreme and we'll head further north, and we'll attempt to better understand Group E in terms of these climactic regions, in this case a polar climate group. Group E, like Group A, represents an extreme rather, in how we look at climates and how we classify different variations in global climates. Polar climates then, in this case being the farthest from the equator, they receive very little insolation or very little sunlight, and really do not experience much warming at all over their annual weather patterns. By definition, no month for a polar climactic group would reach a temperature above 50 degrees Fahrenheit. So they are considered to be always cold. Ground ice is very, very common and is common throughout most of the year. This region encompasses much of what we recognize to be the cryosphere in terms of our understanding of the various geospheres of the planet. So we have the atmosphere, we have the hydrosphere. Within the hydrosphere, we have that portion that's frozen year-round, which is the cryosphere. Within the polar climate region, we recognize three subregions. We have an area of tundra, an area that is generally identified as ice cap, and then we have marine environments where this polar climate is interacting with, in this case, saltwater environments. This would be a polar marine kind of subregion. Polar tundra, for example, exists throughout the Arctic Ocean region. It also is something that we see associated with some of the small coastal areas in Antarctica. So there is both a northern and a southern expression of polar climates. Ice cap regions we find both in Antarctica and in places like Greenland, but Greenland will also express on the coasts that tundra-like environment. As you can see here, as you review some of the details associated with each, all of them have generally the same feel, which is year-round cold, and in this case, precipitation that could be considered in some instances drought, but generally the only precipitation that you're getting is snowfall. Of the three polar subregions, the ice cap climate type is probably the most extreme. You are going to see the most intense temperatures associated with those very cold temperatures. You will also see a greater amount of annual drought, but then what you do get in terms of precipitation is, of course, snow and ice. Now, what's interesting about this region is they have a weather phenomenon known as katabatic wind formations. Generally, the air that we see at the surface of environments that fit the ice cap sub-region is chilled so intensely that it actually is cooler than what is underneath it. It's cooler than the snow and ice underneath it, and it creates this thermal inversion and actually stirs up very heavy, cold air masses that begin to flow across the surface and create this kind of unique downslope wind type. So this is again, like type a very extreme expression of global climate and global climate types.